In this video, we are going to cover how to simplify expressions by doing a couple of different examples. So one way to simplify an expression is to combine like terms. So I've put together one really long example here, and we're going to combine the like terms and simplify this expression. So we have x squared over 2 plus the square root of x plus x minus 3 to the x plus 2 to the x plus log base 5 of x squared plus 3/10 x squared plus 3 log base 5 to the x plus 3x to the 1/2 power. Okay, so let's go ahead and start simplifying this. So right away I notice that I have, let's see, an x squared term here with an x squared term here. So I can do x squared over 2 plus 3/10 x squared, and that is going to be, so if I do 1/2 and 3/10 added together, so that's like 5/10 and 3/10, that's 8/10 x squared, or 4/5 x squared. That's going to give us 4/5 x squared. Okay, so we've got those two out of the way. Alright, what about square root of x? Well, I have one square root of x here. That's just a regular x. Well, I have a 3x to the 1/2. So if we rewrote the square root of x as x to the 1/2 power, then we would get x to the 1/2 plus 3x to the 1/2. So that would be 4x to the 1/2. So we're going to combine this term here and this term here. And again, that is 1x to the 1/2 plus 3x to the 1/2. So that gives us plus 4x to the 1/2. Or we'll just leave it as 4 square root x. It's the same thing. Alright, let's see. We only have one normal x term, so let's just do that. So plus x, so we've taken care of that one. Alright, now we have a minus 3 to the x plus 2 to the x. Alright, so minus 3 to the x and plus 2 to the x. Well, we cannot combine those because they don't have the same base. So we can't just say, negative 3 plus 2 and we get negative 1 to the x, because that's not how exponents work. So those are actually two independent terms. So that's just minus 3 to the x plus 2 to the x. So those remain. So we will, box those off. Those stay the same. We finished those. All right, now we're left with two log base 5. So we have a log base 5 to the x squared and a 3 log base 5 to the x. Well, if we remember our logarithm rules, if you have a squared on the last term there, or any exponent, you can actually bring that out in front. So we can bring that 2 out in front there. So that's going to give us 2 times log base 5 to the x plus 3 times log base 5 to the x. So we can actually combine those. So that gives us plus 5 log base 5 to the x. So now we've combined those last two terms there. And it looks like we're done. So we have simplified that expression by combining all of the like terms. Alright, next examples are adding and subtracting expressions. So Andy and Mary are widget salespeople. Andy makes a flat rate of $10 per hour plus $10 for every widget he sells. Mary makes $12 per hour plus $9 for every widget she sells. So let's write this out. So Andy, Andy equals $10 per hour, so 10h plus $10 for every widget he sells. Mary is going to make $12 per hour plus $9 for every widget she sells. Okay, so which expression best represents how much Andy and Mary make combined in a day if they work the same number of hours? Okay, so if they work the same number of hours, h is going to be the same for both of those. So we're looking for a 22h as the first term. So we have A, B, and E all have a 22h in them. No other 22 terms, just in case they didn't use an h as the variable. So we're looking at A, B, or E. All right, so let's look at the next thing. So we have plus 10w plus 9w. Well, can we combine those? Well, they don't both get paid if anyone sells a widget. They only get paid if they sell their own widget. So no, we shouldn't be able to combine these. Because if Andy sells a widget, he'll get paid $10, but Mary won't get paid $9. So we can't just say 19W, because it's not the total number of widgets the company sells. It is how many each individual sells. So this one immediately is out. And I'll write down, don't double count. Widget sales. For one person. So this is automatically out then, so no. Alright, so now we have well, I guess this one's out too because we don't want to combine them. So that just leaves us with B. So 22h plus 10A, I guess they're using A to represent sales for Andy, because he does $10 per widget, and 9M, and M, I guess, for Mary. So this would be more accurate. So B is going to be our answer. So in that one, we sort of had to add two expressions together, but with a caveat that the W's weren't actually equivalent in those equations. So we could have rewritten the first equation. If instead of a W, we should have changed that to an A, and for Mary, we should have changed that to an M. And then we could have added them together, because the H would remain the same. Okay. Final question. What is the difference between the expression negative x squared plus 3x plus 1 and the expression x squared plus 3x plus 2 when x equals y over 2? Well, we could substitute y over 2 in for every x, but that might be a little complicated. There's a lot of terms here, so why don't we actually subtract first? So because we want to know what is the difference between the expression. So we want negative x squared plus 3x plus 1. Then we want to subtract because we want to know the difference. So minus, let's put this in parentheses, x squared plus 3x plus 2. And we'll put it in parentheses because we do not want to forget to distribute that negative sign. Not distributing a negative sign is one of the most common mistakes on the ACT, and the multiple choice answers will almost always have an answer that makes it where you think you got the right answer, but really you didn't, because they're giving you an answer where the negative wasn't distributed. Okay, so let's simplify this. So negative x squared minus x squared, so that's negative 2x squared. Then we have a plus 3x and then a minus, because we're distributing the negative, so minus 3x. So 3x minus 3x, that's just nothing. So plus 0x. And then plus 1 minus 2. So 1 minus 2 is negative 1. So this simplifies to negative 2x squared minus 1. Okay, now we can plug in y over 2 for x. So negative 2 times y over 2 squared minus 1. All right, and let's simplify that a little bit further. That's going to be negative 2 times y squared over 4, because we squared y over 2, so that's y squared over 4. And then minus 1, and then we can simplify that further to, we're going to simplify negative 2/4 to negative 1/2. So that's just going to be negative y squared over 2 minus 1. And that is the difference between those two expressions.